Okay, so the last type of transformations we're going to look at are dilations. Now, this is where we multiply multiply the x and y by a value. For the reflections, we're multiplying it by a positive or negative. So we're multiplying by a negative, and but for dilation, we're multiplying it by a value. So what you'll end up seeing happen here is you'll see some values change based on some multiplication, and it'll also make sense of this thing here as to why we're multiplying by a. It affects the whole thing, so it's a dilation from the x-axis, and this 1 over n business for this value here comes into play from the y-axis. So if we're dilating from y or parallel to x, we use this matrix here. So we're multiplying k, or we've put a k1 here as the textbook uses, multiply that by x to give us k1x, and y stays the same. If we're dilating from x, then x stays the same, but y becomes multiplied by this k2. So what you'll see happen here is that this is multiplying the y. So this is multiplying the function. So whatever y is, it multiplies that by this thing of k. So that's why it's dilated from the x-axis, which is what we're seeing here. So this multiplies the whole function. So hopefully this will all make sense as it fits in. So what we've got, we'll start with a point like normal, and then we'll have a look at a function as well. So we've got this point 2 and negative 1 is being dilated 3 from the x-axis. So in terms of from the x-axis, we're going to use this. So we're going to have 1, 0, 0, and in k2 our value is 3. So that's what we're going to put in there, 3. Now because it's going from the x-axis, we know that means that what may have started off something like that, it's being dilated from the x-axis, so it will get narrower, it'll move away from the x-axis. So I'd be expecting this value of negative 1 to move away, because that is our height. Now let's have a look, see what happens. So that's what we've got there. Then from there we put in the coordinates of the matrix, so 2 and negative 1, and then we multiply. So this becomes 2, and our 3, negative 1 becomes negative 3. So this ends up becoming 2 and negative 3. So again, it's dilated by a factor of 3 from the x-axis. Now, let's say we've got a function. So we've got y, and this will be squared. I'm going to change this. So let me rub it out. No, it's not let me rub it out. I'll just go over it in red and say that is x squared. So we've got here y equals x squared is gone 3 from y. So because we're dealing from y, we're using this here. So I'm going to write that. I'm going to say x dashed and y dashed equals k1, and k1 in this case is 3, and I'm going to have 0, 0, 1, and then we put in our x and our y. So now from there, what we're seeing happening is that we're left with x dashed equals 3x, and y dashed equals y. So based on this, x will become x dashed over 3, and y becomes y, and y is just y dashed. So now we're going to once again substitute these values into our original equation. So instead of y, we're going to write y dashed, and that equals, instead of x, we're going to write x dashed on 3. So we've got x dashed on 3 all squared. And then we simplify that to make that y dashed equals x squared over 9. And then once again, we need the dash there. And once again, we get rid of the dashes, so it becomes y equals x squared over 9. So it's a dilation of 3 from y, which is represented by 1 over that factor, 1 over 3. Because we're squaring it, it becomes 1 over 9. So that's how we go about doing that's how we go about doing a dilation from x from y with points and with equations.